Hi. In the previous video, we looked at ways to connect to your VPC, which included gateways, VPN connections, direct connect, and peering. In this video, we're going to add some additional security to your VPC by adding network access control lists to our subnets. We're also going to talk more about private subnets and how administrators can still connect to private instances by using bastion instances. In an earlier section, we talked about security groups and how these are like firewalls that protect our instances. An additional type of firewall we can use are network access control lists, or just network ACLs. While security groups surround our instances, network ACLs allow and deny traffic at the subnet boundary, both inbound and outbound. Since we already have security groups, it may seem that network ACLs are a bit redundant. However, best practice is to back up critical firewall rules by including them in both security groups and network ACLs. By default, every subnet already has a network ACL, but they are configured with just one rule: allow all traffic. So technically, you could consider adding any other rules to them to deny traffic as optional, and you could just rely on your security group rules. While this might be okay for low security environments, consider what would happen if someone misconfigures a security group and opens up access to your database to the internet. If you have a deny rule in the network ACL, then no harm would be done, as this would block that traffic. So let's go to the Management Console and take a look at some network ACLs. Click on VPC and then Network ACLs. In the list, you will see the ones that are already created for our subnets. Click on the one for our VPC. Take a look below at the inbound and outbound rules. You will notice there is an allow for all traffic above a deny for all traffic. Network ACL rules are processed in order according to the rule number. Since the allow comes before the deny, the allow has precedence. Click on the Subnet Associations tab, and you will see that the same network ACL is associated with both our private and public subnet. So let's go ahead and make our private subnet more secure. Click on Create Network ACL. Let's give it a name and select our VPC. Let's assume that this is in a subnet we will put some Oracle databases. So let's add a rule to allow that traffic from our public subnet and deny everything else. Click the Edit menu and then add another rule. Enter a rule number such as 100 and then select Oracle for the protocol. For the source, enter the IP address of our public subnet. If you're not sure what this is, go back to the subnets list and get the IP address for the public subnet. And then click Save. Note that this will allow inbound traffic on port 1521 from our public subnet only. All other traffic will be denied. Unlike security groups, network ACLs are stateless, so we have to configure rules for outbound as well. For outbound rules, we need to configure the high ephemeral port range. Click on Edit, add another rule, the port range we should use is 1024 to 65,535. For the destination, put the IP address of the public subnet and click Save. Now let's go to the Subnet Associations tab, click on Edit, and add our private subnet. Now this NACL has replaced a less secure one that was being shared by the public subnet. To follow best security practices, we need to secure our vulnerable instances like back-end app servers and databases in private subnets. In a previous video, we mentioned that NAT instances or a NAT gateway can be used to give our private instances access to the internet to download security patches or to access public AWS services. However, our server administrators will need to be able to connect with our private instances in order to perform upgrades or security updates. Since there is no direct route to the instances from the internet, we need to launch a Bastion instance in a public subnet. The administrators can connect to this instance and from there are able to log into the private instances. The process is different for connecting to private Linux and Windows instances. For Linux instances, we launch a Linux instance as a Bastion and connect to it using SSH with key forwarding. Once logged in, we can SSH to the private instances. For Windows instances, we launch a Windows instance in a public subnet and install RD Gateway. With RD Gateway installed, we use our RDP client and authenticate on the RD Gateway, which then makes an RDP connection to our private instance. For Linux, you don't need to do any special configuration on the Linux instance to use it as a Bastion. With SSH key forwarding, you present the private key for both the private and Bastion instance when you make the connection to the Bastion. Since the Bastion instance receives the private key for the private instance, you can SSH to the private instance after logging into the Bastion. So let's go to the Management Console and demonstrate how this can work. I've created two instances in my VPC. I've got a Bastion instance running in a public subnet, and you can see it has a public IP address. And I've got a private instance running in the private subnet, and it does not have a public IP, so it only has a private IP address. So now what we would like to do is SSH from my desktop computer to the Bastion instance, and then after I log into the Bastion instance, then SSH into the private instance. To make this more secure, check out the security group rules. So if I click on the view rules, I'll see that I have opened port 22 just to my public IP address for my desktop. And for the private instance, I have SSH just to the security group for the Bastion instance. That would mean that this private instance can only receive an SSH connection from an instance in the Bastion security group. Also, if you have made any customizations to your network ACLs, you'll need to update the inbound and outbound rules to allow SSH from the Bastion. Here's our private NACL. Okay, so you see we need an allow for SSH. So we'll click on Edit, add another rule, select SSH, and then for the source, you need to put the IP address of the public subnet and click Save. Okay, so for the outbound rules, we just have to make sure that we have the high ephemeral ports open, and we do, so we should be good to go. So let's go ahead and SSH to our Bastion instance, and then from there, connect to our private instance. On a Mac, you just have to open up a terminal window. Now, because we're going to use SSH key forwarding, we need to add the key to our key store. So for that, you just do SSH-add-k and then the name of the private key. This key we added is the private key for accessing the private instance. If we use the same key pair, then this would be the same key, and we would not have to specify it when we go to connect to the Bastion. For example, we could just do SSH-A and then EC2-user at and the public IP address of the Bastion instance, and that will allow us to connect. However, if we have a different key pair, all we have to do is specify SSH-A and then -I, and then put in the name of the key pair for the different key pair. Okay, and then the same thing. Okay, but for now, let's use the same key pair for both, make it nice and easy, and make our connection. Okay, so we've logged into the Bastion instance, and now from the Bastion instance, we would like to see if we can SSH into the private instance. So we're just going to do SSH, and then EC2-user at, then the private IP address for our private instance. Okay, that's it. Now we've connected to the private instance by going through the Bastion first. If you are using a Windows desktop, you need to use PuTTY to make the SSH connection with key forwarding. If you haven't done so already, convert your PEM key to the PuTTY format. and just save private key. For the next part, you need Pagent. Pagent allows us to store our key in the key store. So let's click on Add Key, select the key, and then close. Finally, we're ready to use PuTTY. For the host name, ec2-user @ and then the public IP of the Bastion instance. Now go under SSH, open up auth, and then allow agent forwarding to allow our private key to be forwarded to the Bastion instance. Now we need to select the key for the Bastion instance. In this case it's the same, so we'll just pick the key and click open. Let's see if we can SSH into the private instance. And there we go. As we just saw, you should configure your security groups to lock SSH connections to certain IP address ranges. For the Bastion instance, you would allow SSH from the IP address ranges for your administrator's network. For the private instances, you can add a rule to security group that only allows SSH from the Bastion security group. For Windows instances, you are using a Microsoft solution for this, Remote Desktop Gateway, or RD Gateway. You just need to launch a Windows instance in the public subnet and make a regular RDP connection to it. Then you install and configure RD Gateway from the operating system. It is also recommended that you install an SSL certificate so that when you connect to the RD Gateway, you can do so over TLS. When you connect to the RD Gateway with your remote desktop client, it will authenticate your credentials and then establish an RDP connection with the private instance. You will then need to log in to that instance as well. For the Bastion security group in this case, we can choose to open port 443 to the internet instead of just to our admin locations. The reason we can safely do this is because we are using TLS for encryption and because we are being authenticated by the RD Gateway. For the security group around the private instances, we open up the standard RDP port 3389 to the Bastion security group. In this video, we talked about how to make your VPCs secure by using network access control lists and Bastion instances. In the next video, we will focus on making your architectures highly available by using multiple availability zones, load balancers, and auto-scaling.